Welcome to the Explainer. Today, we're doing something a little different. We're going to crack open a super technical document, a data sheet for a tiny electronic chip, to find a really big story, a story about a revolution in how we use energy.
So, you've probably noticed this, right? You unplug your laptop charger and it's kind of hot. Or you think about electric cars and wonder, why can't charging be instant? Well, that heat, that waiting time, it's all about wasted energy. It's a symptom of inefficiency. And the answer, believe it or not, is hidden inside a tiny little component, smaller than a credit card.
All right, so here's our game plan. We're going to start with this whole efficiency problem. Then peek inside the power module that's changing the game. We'll look at the secret sauce, silicon carbide, see how it's making a real-world impact, and then zoom out to what it means for powering our future.
Okay, let's kick things off with the big idea here. At the absolute core of this whole story is a really simple but incredibly important goal. We have to stop wasting so much electricity. Think about it. Every single time electricity moves from one place to another, like from the plug in your wall to your phone, or from a car's battery to its motor, some of it just leaks out. It escapes as heat. Now, multiply that by all the billions of devices on the planet, and you're talking about a mind-boggling amount of wasted energy. It's like this invisible leak that engineers have been desperately trying to patch up for years. So, how do you actually fight that waste? Well, engineers have a secret weapon. It's a critical component called a power module. And honestly, this thing is the unsung hero inside so much of the tech we use every day.
And here it is. This is our hero component for today. I know, it looks like a bunch of letters and numbers, but this thing, the Wolfspeed CAB006A12GM3, is a perfect example of this massive leap forward in technology. This is the device we're digging into.
Okay, so what does this thing actually do? The best way to think about it is like a super fast, super smart gatekeeper for electricity. I mean, its whole job is to flick on and off millions of times a second, telling the power exactly where to go and when. And the trick is, it does this so perfectly that almost no energy gets wasted in the process.
So let's translate these nerdy specs into what they actually mean for us. First up, 1200 volts. That's a lot of power. We're talking enough to handle an electric car. Then there's resistance, just 6 milliohms. Now that number is absurdly low. And what does low resistance mean? It means very, very little energy gets wasted as heat. And the kicker? It does all of this and weighs only 39 grams. That's just an incredible amount of power packed into something so tiny.
So the big question is, how on earth does this tiny little module pull all of this off? Well, the answer is in its secret ingredient, the material it's made from. Because this is not your everyday run-of-the-mill silicon.
And this is where things get really interesting. For decades, pretty much all our electronics have been built on good old silicon, and it's served us well, but it has limits. It just wastes more energy as heat, and it can't switch on and off fast enough for what we need now. The new kid on the block is silicon carbide, or SiC, and for high-power stuff, it's just better in basically every way. It's way more efficient, it's incredibly fast, and all of that means engineers can now build things that are smaller, lighter, and way more powerful.
Right there on the first page of the technical sheet, you see these words, ultra-low loss. Now that sounds like marketing speak, but it's not. It's the absolute core promise of silicon carbide. It means for every bit of power that goes in, almost all of it comes out the other side. That incredible efficiency, that's the whole ball game.
Here's why its speed is such a game changer. Silicon carbide can switch on and off way faster than silicon, like more than 10 times faster. And because it can do that, all the other parts in the system, things like capacitors and inductors, they can be made much, much smaller. It's a direct chain reaction. The faster switching speed is exactly what lets us shrink everything down. I love this analogy. Think of it like a water faucet. An old traditional silicon faucet, it's kind of leaky. Every time you turn it on and off, it drips a little bit. Wasted water, right? Now, a silicon carbide faucet is brand new, perfectly engineered. It snaps on and off instantly. No drips, no waste. In the world of electronics, that drip is what we call switching energy loss. And this module, it basically has none. Okay, so this is all very cool on a technical level, but what does it actually mean for us, right? How does a tiny, better switch actually lead to a better world?
Well, the benefits just ripple out through the whole system. Because this one part is so efficient, you can suddenly build smaller and lighter products. Because it generates less heat, you don't need giant, clunky fans or big metal heat sinks anymore. And here's the really cool part. Even though this chip is more advanced, by getting rid of all that other bulky stuff, it can actually make the entire system cheaper to build.
And where is this stuff actually showing up? The data sheet lays it all out. We are talking about the absolute core technologies for a greener future. Things like way more efficient EV chargers, the inverters that take power from solar panels and feed it into the grid, and even the hardware that's making our entire power grid smarter. This little module is right at the heart of all of it.
Let's just zoom in on that EV charger for a second. You put a silicon carbide module inside, and bam, the whole charger can be way smaller. Since it's not wasting a bunch of energy as heat, it's more reliable. And because it's so good at managing power, it's helping clear the path for even faster charging down the road. It's really that simple. Better parts literally build better products.
All right, for our last section here, let's pull the camera all the way back and look at the biggest possible picture. Because this was never just about one little component. It's about everything that component makes possible.
And this really tells the whole story, step by step. It all starts with a better material, silicon carbide. That lets you build a better component, our power module. That better component lets you build better systems, like EVs or solar inverters. And when you add up all those better systems, you get the huge impact, a cleaner, smarter, more sustainable energy future for all of us. And really, that's the key takeaway here. What we've found hiding in that technical document isn't just a small improvement. It's a fundamental change in how we handle electricity. It's a genuine leap forward that lets us do so much more with so much less. Less waste, less size, less energy.
So the next time you plug something in, or you see an EV charger, maybe you'll remember the story that's happening inside. That there's this tiny, incredibly efficient gatekeeper just working away, managing all that power. And it kind of leaves you with this one last question to chew on. If a revolution this big can start with a component this small, what other massive breakthroughs are hiding in plain sight, just waiting to change our future?